1959, the year the Bentley Continental S2 was built. I have wanted one of these for a long time. Now one is in the workshop. The S2 Continental was the first Bentley to use the new V8 engine. The straight six from the S1 was gone. You can feel the difference just looking at the engine bay. Wider, lower, more purposeful. The V8 displaced 6,230 cubic centimeters. Rolls-Royce and Bentley never published a power figure. The answer was always the same: sufficient. That was the official answer. And on this car, it still is. This body was built by H.J. Mulliner of Chiswick. The fastback coupe design. Fewer than 400 were made. The proportions are extraordinary. That long, fastback roofline, the short tail, nothing else looked like this. H.J. Mulliner had coach-built for Bentley since before the war. Each body was fitted by hand to the chassis. The panel fit is still perfect after 65 years. That tells you everything about how it was made. The color is shell gray, a shade that Bentley offered specifically for the Continental range. Shell gray with red leather inside. That combination was favored in the period. It works. The Continental chassis had a higher compression ratio than the standard S2, set up for performance. Engine turns freely by hand. That is a very good sign on a car that has been standing. Bentley fitted a higher rear axle ratio in the Continental. It was built for long-distance touring, not town use. Axle ratio difference you actually feel. This car would cruise at 90 miles an hour without effort. In 1959, a Bentley Continental S2 cost more than 4 average houses in London. The cost of admission then, the cost of proper restoration now, different sums, same commitment. The Flying Bee mascot on Mulliner bodies was a larger casting than used on the standard saloon. Mascot is here, still on the car. Not many survive intact. Bentley used a separate body and chassis. The chassis was hand-finished at the factory in Crewe. Chassis plate reads, Derby, 1959. Before the move to Crewe was complete, the gearbox was a GM turbo-hydromatic unit, extensively modified by the factory for the Bentley character. Fluid in the gearbox is dark, but present. It will need changing before any real test. All 4 brakes were drums on the S2. Disc brakes did not arrive until the S3 in 1963. Drum brakes on all 4 corners. Properly set up, they stopped this car fine. They just need adjustment. Front drums are seized, both sides. They have not moved in years. Seized drum brakes on a stored car are expected. The shoes bond to the drum surface with moisture. You heat them, shock them, and they release. Or you replace them. Either way, it is fixable. The S2 used kingpin front suspension, not ball joints. An older design, but exceptionally durable. Kingpins are worn but present. Replacements can still be sourced. Kingpin wear shows as steering vagueness. Tighten the kingpin and the steering transforms. Steering wanders at the moment. That will change once the kingpins are done. The engine block was cast iron with wet liner bores. The liners can be replaced without machining the block. Wet liners mean you can rebuild this engine without specialist machining. The block survives. Cast iron wet liners were common in commercial vehicles, but rare in luxury cars of this era. Bentley chose reliability over lightness. The right decision for a car meant to last a century. The cylinder heads were aluminum alloy. Expansion difference between block and head had to be managed precisely. Head bolt torque sequence on these engines is specific. Miss it and you warp the head. The S2 engine produced approximately 178 brake horsepower, enough to reach 120 miles per hour. 120 miles an hour in 1959. That was extraordinary for a 2-ton car. The Continental body weighed less than the standard saloon despite looking larger. Aluminium panels throughout. Lift the bonnet and feel it. Aluminium. You notice immediately. Aluminium panels were used for the doors, bonnet, boot lid, and roof. Steel only for the floors and sills. No rust on the aluminium sections, as expected. The steel sills are where to look. Offside sill has surface rust, not through rust. Surface only. Surface rust on steel sills is treatable without panel replacement if caught before it perforates. The Mulliner body was constructed on a separate jig from the standard S2 saloon. Each Mulliner body took 3 months to build, hand-hammering aluminium over wooden bucks. Wooden bucks were the templates over which the aluminium was beaten into shape. That technique produced curves impossible to achieve by pressing, each panel unique. The A-pillars on the Continental are integral to the structural strength of the fastback design. A-pillars look solid. No rot at the base. That is excellent news on a convertible-bodied derivative. The boot of the Continental S2 was smaller than the saloon. The fastback ate into the luggage space. Boot lid opens cleanly, no binding. Hinge pins are worn but functioning. Bentley fitted matching luggage in the boot as standard on some Continental specifications. No luggage here. But the boot lining is original. The press studs are even intact. The dashboard layout on the S2 was a development of the R-type Continental design from 1952. Same clock position, same gauge cluster arrangement. 7 years of evolution, but clearly the same family. Radio is still here. Period Radiomobile, still wired in. The Radiomobile was a factory-fitted option, preset to BBC frequencies. The steering wheel was a 4-spoke design, similar to Rolls-Royce, but with Bentley badging at the center. Wheel is original. The leather wrap has dried, but it is intact. Interior leather on the S2 Continental was sourced from a specialist tannery in the English Midlands. Red leather has faded, but not cracked. The dye has gone from the bolsters, but the grain is perfect. Interior leather on a stored car fades evenly. Uneven fading suggests repairs or replacement sections. This leather has faded evenly across the whole car. It is all original. The rear seat on the Continental S2 was smaller than the saloon. It was a 2+2 configuration. Rear seat is dry. Headroom in the back is tight. It was never designed for rear passengers on long trips. The headlining in the Continental was a fine wool material, fitted to the fastback curve without seams. Headlining is sagging at the rear. The adhesive is gone, but the material itself is undamaged. Fitting a new headlining to a fastback is more complex than a saloon. The curve compounds over its length. It will need a specialist trimmer, not something to attempt without the right experience. The carpets in the Continental were a Wilton weave, cut to fit over the transmission tunnel. Carpets are original, dry and stiff, but not rotted. The transmission tunnel in a Bentley of this era ran the full length of the cabin floor. Tunnel has no heat damage. Insulation is still in place. The wood veneer on the dashboard was hand-selected and matched. 2 pieces from the same tree section. Veneer is lifting at one corner. The rest is perfect. 1 repair job. Found a service record in the glove box, last serviced in 1987. A service record from 1987 means the car was running and maintained into the late 1980s. 35 years of storage after a service record. Not unusual for a car of this value. It stopped being driven rather than broke down. That is the best kind of stored car to find. A car that stopped running rather than a car that was stopped. The difference matters in restoration. No evidence of a problem that ended the driving life. It was simply put away. The fuel tank on the S2 held 19.5 gallons. Tank is empty and dry. No varnish smell. Whoever stored it drained the tank first. Draining the tank before long-term storage prevents varnish deposits from blocking the jets. Someone knew what they were doing when they put this car away. That care shows throughout. The Brakemaster cylinder on the S2 was a single-circuit design. Safety regulations had not yet required dual circuits. Master cylinder is dry. Seals will need replacing before any brake testing. The fluid in a single-circuit brake system absorbs moisture over time, which lowers the boiling point. Completely fresh fluid throughout before the car moves under its own power. Non-negotiable. The front suspension geometry on the S2 Continental was set up for high-speed stability on continental roads. Caster angle looks correct. Someone set this car up properly before it was stored. Correct caster angle gives a car its tendency to return to straight after a corner. The steering self-centers even with worn kingpins. The geometry is still right. The rear suspension was a conventional live axle with coil springs and dampers. Rear dampers are leaking, both of them. That is expected after 35 years. New dampers are available for the S2. The standard specification fits the Continental axle. Dampers on order. 2 weeks. Everything else on the suspension can wait for those to arrive. The exhaust system on the S2 ran twin outlets on each side, 4 pipes in total. 2 of the 4 pipes have rusted through. The other 2 are marginal. Full replacement. Stainless steel exhaust systems are available for the S2 and will outlast the original by decades. Stainless steel system on order with the dampers. Might as well do the underside properly. The underside of the Continental was zinc painted at the factory and covered in underseal. Underseal has lifted in places. Clean it back. Treat what is underneath. Reseal. Standard procedure. The body mounts connecting the body to the chassis use rubber isolators. All need replacing. Rubber mounts have hardened. They are transmitting vibration directly into the body. That changes. Jacked up now. full view of the underside under workshop lighting. What you find under a stored car is always a combination of the expected and the surprising. On this car, the surprises are mostly positive. The structure is sound. The chassis rails are solid, both sides, no flexing, no cracks, no repairs. A solid chassis is the foundation everything else is built on. Without it, the cost doubles. With a solid chassis like this, the restoration has a clear path. Difficult, but clear. The floor panels are steel, 3 sections, front, transmission, rear. Front floor is clean. Transmission floor has surface rust. Rear floor is dry. Surface rust on floor panels is treatable with rust converter and epoxy primer. No holes anywhere in the floor. That is the key point. No holes. A floor without holes means the interior is structurally dry. Water has not been sitting in the car. Confirms what the carpet told us. This car has been dry throughout its storage. The fuel lines on the S2 are steel. After 65 years, replacement is precautionary rather than reactive. Fuel lines will be replaced in full, not worth the risk of a failure. The brake lines run alongside the fuel lines on the outboard side of the chassis rail. Brake lines are original, copper and nickel alloy, still in good condition, but they will also be replaced. Everything on the underside is assessed. The list is long, but there are no shocks on it. The engine is out on the stand now. 65 years of history in one casting. First thing you notice is how clean it is inside. Someone maintained this engine properly. The V8 in the S2 was an entirely new design for Bentley, sharing nothing with the old straight six. The bore spacing, the deck height, everything different. A proper clean sheet engine. The cylinder liners are wet. They sit directly in coolant. Remove them without disturbing the block. Liner removal tool goes on. First one out. Clean bore underneath, second one the same. New wet liners are available as service items. The block itself can last indefinitely. All 8 liners are coming out, new ones going in. While the engine is apart, do it right. The crankshaft on the S2 engine was cross-drilled for improved oil delivery to the big end bearings. Crank journals are within tolerance. No scoring. This crank does not need regrinding. A crankshaft with intolerance means the engine was regularly serviced throughout its working life. The service record from 1987 suggests regular care up to that point. The crank confirms it. New shell bearings are fitted regardless of measured tolerances. The cost is low. The benefit is certain. Main bearings out. Crank lifted. New shells dropped in. Torqued to specification. The connecting rods on the S2 engine are forged steel. Original specification is still the correct specification. All 8 rods are straight. No bending, no twist. They Piston rings seal the combustion chamber against the cylinder wall. New rings on all 8 pistons. Ring gaps checked and set before assembly. The camshaft on the S2 engine operated via push rods and rocker arms. An overhead valve design. Camshaft looks fine. Lobes are not worn. It will go back in as it came out. The timing chain on the S2 engine drove the camshaft from the front of the crankshaft. Timing chain has stretch. New chain and tensioner. While the front cover is off, replace the oil seal as well. The oil pump on the S2 was driven directly from the camshaft. Oil pump is out. Clearances are marginal. New pump on order. An oil pump with worn clearances drops pressure at idle. Low oil pressure at idle is the engine telling you something. New oil pump will give full pressure from cold. That is what this engine deserves. Cylinder heads off, both of them on the bench. The aluminum heads on the S2 are prone to warping if the engine overheated at any point in its life. Heads are going to a machine shop, surface check, pressure test, valve seat recut. Standard procedure. Valve seats in aluminum heads harden over time. Recutting them restores a gas-tight seal. Machine shop report back, both heads are flat, no warping. Good news, flat heads mean the head gaskets sealed correctly throughout the engine life. New gaskets on both heads. New head bolts as well. Do not reuse head bolts on an engine this old. Head bolt stretch is cumulative. A bolt used once and retorqued loses some of its clamping force. New bolts cost very little. The alternative is a failed gasket 6 months after completion. The twin S-U carburetors on the S2 are a matched pair. They must be rebuilt and balanced together, both carbs stripped completely, every rubber part replaced, jets cleaned and measured. SU carburetors use a variable jet that rises with throttle demand. Simple in principle, precise in execution. Float heights set identically on both. Airflow balanced on the bench. They will need final tuning on the engine. The distributor on the S2 used a vacuum and centrifugal advance mechanism. Distributor cap is cracked. Points are worn. New cap, new points, new condenser. Ignition timing on the S2 was set at the factory for the fuel octane ratings of 1959. Modern fuel has a different octane profile. Timing will be adjusted on the rolling road. The cooling system on the S2 used a pressurized radiator and an electric cooling fan. Radiator core is blocked, sending it for a chemical flush. If it does not clear, it gets recored. A blocked radiator causes slow overheating, the most damaging kind because it is easy to miss. New thermostat, new hoses, new clips, everything in the cooling circuit that can be replaced will be. The gearbox oil on the S2 was a specific viscosity that the factory recommended changing every 24,000 miles. Gearbox drained. Old oil is dark but not burned. Box is probably fine. Fresh fluid and a road test will confirm. Automatic transmission fluid carries heat away from the friction surfaces. Old fluid loses that capacity. Fresh fluid in. Filter changed. Sump gasket replaced. Gearbox is ready. The front brake drums on the S2 were finned aluminum for heat dissipation. Drums are seized. Heating them with a torch now. That smell is the rust releasing. A seized drum brake can shatter if excessive force is used to free it. Heat is the correct approach. Both front drums are free now. Shoes are bonded to the surface. New shoes on both sides. Brake shoe lining material degrades over time regardless of use. Age alone is reason enough to replace them. New shoes on all 4 corners. New wheel cylinders, front and rear. Hydraulic system rebuilt entirely. The rear brakes on the S2 used a separate handbrake mechanism acting on the inside of the rear drums. Handbrake mechanism is intact. Cable is frayed at one end. New cable on order. New kingpin sets arrived this morning. 2 hours each side to fit them. Kingpin replacement requires the front hub to be removed and the knuckle pressed off the pin. A correctly fitted kingpin has defined play measured in thousandths of an inch. First side done. Zero play, smooth rotation. That is what correct feels like. The second kingpin always goes faster than the first. You have already solved every problem once. Second side done. Both kingpins fitted. Steering already feels different just moving the wheel by hand. After the kingpins, the front wheel alignment must be reset to the factory specification. Alignment, jig setup, caster, camber, toe. All three axes checked and set.
Caster is the rearward tilt of the steering axis. It governs straight-line stability. Caster is right. The suspension geometry was preserved through storage because the car was never in a collision. The tires on the S2 were originally cross-ply construction.
Radials were introduced later in the production run. The car has period radials already fitted. Someone upgraded them correctly some years ago. Radial tires on a car set up for cross-ply require a slight modification to the steering geometry. Geometry adjusted for radial specification, it changes the feel at the steering wheel in a positive way. New dampers arrived for the rear axle. The specification matches the original Continental setting. Rear dampers fitted. Axle compressed and released. Movement is controlled and even. The rear ride height on the S2 was fixed. No self-leveling as found on later models. Rear springs are original and still within height specification. They do not need replacing. The stainless steel exhaust system arrived from the fabricator. New exhaust going on now, 4 pipes, twin outlets each side. The sound of this engine will be different with free-flowing pipes. Exhaust back pressure affects engine torque. Too much, and you lose low-end pull. Too little, and you lose mid-range. Fabricator matched the original pipe diameter. Back pressure will be the same as factory. The underside treatment begins with removing all loose material back to bare metal. Wire wheel on the angle grinder. Every section of the underside stripped. Bare steel on a Bentley chassis should be treated within 24 hours to prevent flash rust in humid conditions. Rust converter on first. 2 coats, then epoxy primer. Then the sealing compound. The Bentley factory used a bitumen-based sealing compound on the underside. Modern equivalents are more durable. Modern, rubberized underseal going on, thicker than original but more flexible. It will not crack. Flexibility in underseal matters because the body moves relative to the chassis on rough roads. 3 coats of underseal on the floor sections, 2 coats on the chassis rails. Done properly. The fuel and brake lines were replaced with new copper-nickel alloy tubing. Copper-nickel does not rust. The original steel lines lasted 65 years. These will last longer. All new lines were pressure tested before the underside was sealed. Pressure test on the fuel line, no drop over 30 minutes. Brake line, no drop at all. Both are right. With the underside complete, attention moves to the body surfaces. Shell gray under the old paint needs checking. Scanning a panel now for the original formula. The spectrometer reading matches the factory record. The formula has not drifted over 65 years. Same color it left the factory. Good. We can match it exactly. Paint mixing for a Bentley Continental is done in small batches to ensure consistency across panels. Paint mixed and tested on a card against the door jamb. Match is exact. 9 coats of paint are applied to a Bentley at the factory. The restoration will match that. First coat of epoxy primer on the bodywork today. You can already see what the car will become. Each coat of primer is flatted by hand with wet and dry paper before the next coat goes on. Flatting is slow. It is also the only way to achieve the depth of finish this car deserves. The shell of the car is taking shape. The process is halfway through. The direction is clear. The engine is back in the car. The moment the engine goes back in, the project changes character. Engine mounts torqued, gearbox bolted up, exhaust connected. It looks like a car again. First coolant fill after a rebuild requires bleeding air from the system at the highest point. Coolant in, bleeding the top hose. Watching the temperature gauge come up slowly. An engine that has been rebuilt should not be run at high load until it has reached operating temperature, idling at 800 revs. Temperature climbing, oil pressure steady, everything reading correctly. The first hour of running after a rebuild beds in the new rings against the fresh liners. Letting it idle, listening. No knocks, no ticks, no hisses. It sounds exactly as it should. The twin SU carburetors need final balancing with the engine warm and at idle. Balancing the carbs now, lifting each dashpot in turn, equal rise, equal drop, balanced. Ignition timing is set on a warm engine using a strobe light against the timing marks on the crankshaft pulley. Timing set, vacuum advance, connected, idle quality improved immediately. A correctly timed engine at idle should be smooth, quiet, and willing to rev cleanly from low speed. Blip the throttle. Clean response. No flat spot. The carburetors and ignition are working together. The brake system is bled starting from the wheel furthest from the master cylinder. Bleeding rear near side first. Clean fluid coming through. Pedal pressure building. Brake bleeding removes air from the hydraulic circuit. Air compresses. Fluid does not. All four corners bled. Pedal is firm. Brakes are ready for their first test. Chrome work is one of the most visible elements of a completed restoration. First chrome pieces arrived back from the platers. Headlamp, bezels, front bumper, overriders. Triple plating adds copper for adhesion, nickel for depth, and chrome for hardness and reflectivity. The finish is perfect. You can read text in the reflection of the overriders. The Flying Bee mascot was recast from the original, a new casting plated to the same specification. Mascot fitted to the bonnet. It sits exactly where it should. The proportions are right. Interior work on a Bentley Continental begins with the structure, the door cards, then the seats. Door cards are stripped back to the backing plates, padding replaced, new leather cut and fitted. The leather on the door cards was cut to match the original stitch lines. Exactly. Piping restitched, panel fitted. The seam alignment with the seat leather is correct. The seats were stripped to the frame. Springs checked, padding replaced, leather fitted. Red leather from Bridge of Weir. Same tannery as the original, the grain is a match. Leather dyeing brings faded sections back to the original color depth without replacing the hide. Dye application is by hand, not spray. You build the color in layers until it matches. A skilled leather craftsman can make a 65-year-old hide look factory fresh. Seats back in the car. The red against the shell gray exterior is exactly as it was in 1959. The dashboard veneer was refinished with 12 coats of lacquer, flatted between each coat. The grain of the walnut has come back under the lacquer. It has real depth now. Original walnut veneer from 1959, properly finished, cannot be replicated by modern reproductions. It is the same wood it always was. We have just reminded it. The headlining was fitted by a specialist trimmer with experience of fastback Bentleys. Watching the trimmer work the material over the rear curve, no creases, no joins visible. A one-piece headlining on a fastback requires the material to be pre-tensioned at multiple points simultaneously. 2 hours. For the headlining, it looks as though it was always there. The Wilton carpets were refitted over new sound-deadening material. Carpet clips back in. Sound deadening adds weight, but it transforms the cabin noise. Sound deadening in a 1959 Bentley was minimal by modern standards. New material is thicker and more effective. The cabin is noticeably quieter than it would have been originally. That is not a compromise. That is an improvement. The clock in the center of the dashboard was serviced and the mainspring replaced. Clock running, keeping accurate time. It will be reset at delivery. The Radiomobile radio was refurbished by a specialist in period audio equipment. Radio Works picks up FM with a period-correct aerial. Not what it was designed for, but it works. All instruments were removed, cleaned, and recalibrated, every gauge reading correctly. The oil pressure gauge was sticking at the top of its range. Needle pivot replaced. The steering wheel leather was rewrapped to the original stitch pattern. 4-spoke wheel rewrapped. The diameter is larger than any modern car. It fills the hands properly. The first full road test covered 70 miles. Out of the workshop and onto the road. First impression, the gearbox is smooth. Very smooth. A rebuilt automatic gearbox on a car of this weight should shift without any jolt at normal road speeds. Upshifts are seamless. Kickdown is responsive. The gearbox is working exactly as it should. The brakes were bedded over 12 gentle stops from 40 miles per hour. Brakes, progressive, and even, no pull left or right. Drum brakes get a bad reputation they do not deserve when set up correctly.
The condition of this wet liner indicates significant bore wear.
The steering feel after new kingpins and correct
Bring it down
geometry
slowly.
is a transformation.
Careful. To the right, just a
Two
little.
fingers on the wheel
Got
at
it.
70
Perfect.
miles
Forward.
an hour.
Done.
It tracks
Let's check the
straight
rounds.
and comes back to center without prompting. The suspension was checked on the road for any unusual noises or movement. Smooth over expansion joints, no knocking over potholes. The dampers are working correctly. Top speed on the first road test was kept below 60 miles per hour. The engine is still running in. At 60 miles an hour, the engine is barely awake. It is pulling easily, asking for more. The second road test took place after 500 miles of gentle running. 500 miles done. Oil changed. Coolant checked. Everything is still correct. After the running-in period, a final rolling road session sets ignition timing and carburetor mixture precisely. Rolling road session complete. Power output confirmed at 172 brake horsepower. Right where it should be. The body panels were inspected for any imperfections before the final coat of paint. 2 small areas needed guide coat flatting. Everything else was ready for top coat. Guide coat is a thin spray of a contrasting color. It reveals low spots when flatted back. Low spots filled, flatted. Guide coat removed. Panels are now perfectly flat. The top coat of shell gray is applied in a booth at a controlled temperature and humidity. First panel done. The color in the spray booth looks different to how it will look in daylight. Paint color perception changes with light source. A spray booth uses daylight balanced lighting for this reason. All panels painted 24 hours to cure before any handling. Rubbing out the final paint coat requires progressively finer grades of abrasive paper and compound. Working through 1,200, 1,500, 2,000, then cutting compound. The depth is building. The final polish is applied by machine and finished by hand. Machine speed, human judgment, shell gray in sunlight for the first time. The depth in this paint, extraordinary. Chrome pieces are fitted last after painting to avoid any risk of paint damage. Grille going on, headlamp bezels, overriders, bumpers, mascot. The assembly sequence of chrome work is important. Each piece affects the fitting of the next. Everything lines up. The gaps are even. The chrome and the gray work together exactly as intended. The final inspection covered 240 individual points, going through the list methodically, 1 point at a time. Panel gaps were measured at every point. A credit card width is the maximum permitted. All gaps within tolerance. Boot, bonnet, doors. The body is as it left H.J. Mulliner. The completed car was weighed. It had lost 9 kilograms through the restoration process, 9 kilograms lighter. The weight of 65 years of accumulated corrosion and failed repairs. The odometer read 31,000 miles when the car arrived. It reads the same now. Every mile on that odometer was covered by this car. Not a single one added in this workshop. A Bentley Continental S2 restored properly will outlast everyone working on it. That is the point of the work, not to own it forever. To give it the next 65 years, 14 months, 310 hours of labor. One Continental, 14 months, worth every one of them. The owner arrived on a Thursday afternoon in late October. He walked around it twice before saying anything. Then, exactly right. The Bentley Continental S2 was designed to be the finest touring car in the world. Drove away in first gear, into second, into third. The engine settling into its stride. 65 years, and it is back where it always should have been, on the road.